Students, as you can see, today we are going to start a new chapter, that is application of trigonometry. Now, application of trigonometry, and what you got that last, that trigonometric ratios. Actually, from trigonometric ratios, application of trigonometry. Now, basically, what we study in the application of trigonometry. Application, remember, whatever you have studied, you will apply in this chapter. Actually, here we will study that how to measure the height. Now, what is the height? Height of a building, height of a tower, height of a tree, height of a high-raised tower. So, for this chapter is used. And in this chapter, we'll use to calculate the height and the distance between the object and the foot of the tower or foot of the building, or length of the rope, by using trigonometric ratios. Now, only trigonometric ratios is not that. Also, trigonometric ratios along with specific angle. You got trigonometric ratios, and how many trigonometric ratios? There are 6 trigonometric ratios, and in these 3 and 3 are the main, and their reciprocal is the another 3. So 3 plus 3 is the 6. That is sine. Reciprocal of sine is cosec, or reciprocal of cosec is sine. That is vice versa. The next, cos, reciprocal of cos is sec, and reciprocal of sec is cos. So vice versa. So 2 to 4. And the last one is tan and the cot, and reciprocal of tan and cot, or cot and tan, and vice versa. So these are the main thing we'll use, and also we'll use that what is the value of tan 30 degree, what is the value of tan 60 degree, what is the value of sine 45 degree. Those things we'll use here. Now here basically 2 objectives we will find. One objective is the short-term objective. What is that short-term objective? Short-term objective is that by using this, you will be able to solve the question given in your book, or that whatever question will be given in your worksheet or the reference book and all. And also, by using this, you will apply, you will solve the question in exam, and you will secure the marks. But what is the long-term application? Long-term application is that you have seen in the science that how to measure the height of the shadow, how to measure the height of the pole. So here we'll use these for a long-term objective. That is, suppose when a tower will be installed, they have to see that to what distance they will elevate that one. Or when a scientist release a space shuttle, what angle they have to release. Okay? Now, there in this chapter, there are 2 angles you will find. You have got so many angles in your earlier classes and all. Here, 2 angles, 2 very important. One, when you are looking up, upward looking. When, suppose, if this is the tower, if I keep the tower here, and if I see this way, this is the way I am looking. And this, if you see that to my side, this is the one, then this is, and this one I am standing along with the base, and this line is a line of sight, and the angle, you can see the angle formed with this line is called angle of elevation. Once again you see, suppose this is the height of the tower and I am looking from here, then this is the one, then this angle formed by this end is the angle of elevation. Clear? So when you are looking up to see an object, suppose a bird is flying, that is the angle of elevation. Now how angle of elevation is formed? See once again. See, angle of elevation is formed with my side. This is my side. This is my side. If you see, this is my side. Side and the line of sight. This is the line of sight and with the base. So these two lines, this one and this one, is forming the angle of elevation. Now, what is angle of depression? Angle of depression is that, suppose you are standing here and you are looking down. Suppose this is an object and I am looking down. This is also line of sight, but I am looking down. Then this one will be the line of sight. Then how it will form? It will form by, suppose I am holding. This is the object I am looking, and this is the one I am looking, and see this one is the angle of depression. This will be a virtual line will be drawn along with the base. That means when you are looking an object down, suppose you are standing in the first floor and you are looking an object in the ground floor, there is a line of sight going down. When the line of sight is going down, that one will form that angle of depression. And when you are looking from the ground floor to the top floor, then there is an angle of elevation. But remember one thing, that angle of depression and angle of elevation ultimately is same. How it is same? Because you are drawing a virtual line. Along with this, and this is that line of sight. So this is a transversal, and this virtual line will be parallel to the base. As it is parallel to the base, then you know the condition of a pair of parallel lines and a transversal, that alternate angles are equal. So my dear student, once again, two objectives, one short-term objective and the long-term objective. Long-term objective is that, suppose you are becoming an engineer and all, or you are a scientist, that when you have to launch a space shuttle, that you have to calculate at what angle you have to release it. There, this application of trigonometry. To measure the height of the tower, suppose installing a tower, big tower, that is the application of trigonometry. And short-term objective is that, as of now, you are not neither an engineer nor a scientist. Your basic focus is that how to solve the question if related to how that angle of depression and angle of elevation is found. Okay? And then what I told, there are two, that angle of depression, angle of elevation. And both are same. Ultimately you have to convert and then you have to see. And basically, here one more thing you have to remember. Basically, we are using either tan, cot, or sine and cos. Basically, sec and cosec. Use of sec and cos is very, very less. Most often, you will use that tan theta. Okay? Now, another thing is that, for your information, I want to say that you have to remember the ratio of the sides for the tan, ratio of the side for your cot, ratio of the sides for sine and cos. Okay? Now, let's see. You can see that I have drawn two diagrams. Now, one diagram, this is my eyesight. When I am looking towards up, you can see my eyes is looking up, then this is the angle of elevation, and this is the line of sight. Remember one more thing. Here, already the last chapter also told that trigonometry relate to right angle triangle. So that means this angle should be 90 degrees. That is right angle. And this another one you can see, as I told, the virtual line. So that is the reason it is that dotted line drawn, this line parallel to this line, and this is the transversal. Then what will happen? That this angle will be equal to this angle, and why they are equal? Alternate angles. Then you can see the arrow is downward. So this is angle of depression. Line of sight will be there. Without line of sight, angle of depression and angle of elevation will not form. And here you can see that arrow is upward, arrow is downward. Clear, my dear student? So now let's see how to use this thing in our exercise. In the exercise, that very first question is that you see a circus artist. Circus is a very, very interesting part of our life where we can see various activities shown by the people or by the animals and all, where we can see amazing activities. So a circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. Diagram already given. Remember, in this chapter, another important thing is the diagram. If you are not able to draw the diagram properly, you will not get a right answer. So diagram is the most important factor. Okay? So let's see. See here, A, B, C, this is 30 degree. Exercise 9. Actually, here it is given exercise 9.1, but only one exercise, so 9. So, and 20-meter rope. 20-meter rope. And what do you have to find? You have to find the height of the pole. You have to find the height of the pole. This is the height of the pole. Now you see, in the last chapter I told that side opposite to the angle is perpendicular. So hypotenuse is there, and you have to find out this one. So now, which ratio you have to use? I have to use this side AC, I have to use A. That is perpendicular and hypotenuse. If I have to use perpendicular and hypotenuse, which is the trigonometric ratios? Obviously, sine. So see here, AB equal to question mark, AC equal to 20 meter, angle C equal to 30 degree. Question number 1. Diagram already given. So then what you have to do? Sine C. Sine angle ACB equal to AB by AC. Perpendicular by hypotenuse. So it is 20, AB by 20 equal to sine 30 degree. Then what is that? It will be ultimately AB equal to half into 20. So it will be cancelled. 10 equal to 10. So therefore height of the tower is height of the pole is 20 meter. Height of the pole is 20 meter. This is not the answer. You have to write down answer again. Therefore height of the tower is 20 meter. So this is the answer solution of question number 1. Now let's see question number 3. Question number 2 is also almost same. So just you have to draw the diagram, almost same diagram, and you try. Now question number 3. A contractor plans to install 2 slides for the children to play in a park. Slide you have shown that you have to climb from the back, that is from this side, perpendicularly you have to climb, and then you have to slide down. Okay? So 2 for the children below the age of 5 years, she prefers to have a slide whose top is height 1.5 meter, that is that perpendicular height, and he is inclined at an angle 30 degree. Whereas the elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? Remember one thing. More the measure of the angle, more will be the height. Less the measure of the angle, less is the height. Okay? So let's see. I hope all of you have written this one, so I'll draw. Question number 3. Same. 1 slide. This is 5 years. Another how much told? And whereas elder children, that means this is greater than 5 years. Greater. Okay? Here you see it is 30 degree. It is 1.5. This is 60 degree. See, this is 3. So see, angle double, height also double. I told already, more the angle, more will the height. So you put 1 by 1. Slide will not be straight as such, little bit slanting. So this is A, B, C, this is P, Q, R. Okay? 2 cases. You will get 2 answers. So what they are asking? They are asking what should be the length of the slide. That means you have to find out this part. You have to find out this part. See, in the last question, hypotenuse was given. Now in this question, voltage is given. And you have to find out the hypotenuse. So here also same, you have to use sine. So first of all, you please write down AB equal to 1.5, angle ACB equal to 30 degree. Here PQ equal to 3 meter. Angle PRQ equal to 60 degree. And then both sides, here you have to find PR question mark Here you have to find out AC equation. Okay, these are the things you have to write it down, and then you start. Okay, for first one, suppose for triangle ABC. What is that? Sine angle ACB equal to AB by AC. Remember, this is the most important part. That side opposite to angle considered is perpendicular. So sine 30 degree equal to 1.5 by AC. What is that? Half. 1.5 by AC implies AC equal to 3. That means in the first case, the length of the side is 3 meter. Length of the side is 3 meter. Let's see the second case. That is for triangle PQR. Okay? Sine angle PRS equal to PQ by PR implies sine 60 degree equal to 3 by PR implies root 3 by 2 or root 3 by 2 equal to 3 by PR. Then ultimately what will be the answer? Implies PR equal to, if I cross multiply, then it will be 2 root 3. 2 root 3. So 2 root 3 value you know, 1.732. But no need. You can directly write. Okay? So 2 root 3. Therefore, the length of the slide in the second case will be 2 root 3 meter, and the first case will be 3 meter. Clear, my dear student? So please remember one thing, that you have to draw the diagram correctly. Two separate diagram I have drawn. Instead of that, you can look one diagram also. It is possible. One diagram how? I'll show you. See, this is one, and this is the other. Okay, this is 60 degree. This is 30 degree. These are also possible. Only climbing will be here. Climbing will be here for this, and for here it will be for this part, and for this part. Okay, clear? So this diagram also, but I will prefer that you draw this diagram, then confusion will not be there, and it will be easy to understand also. Okay, so this is the question number 4 and 3. Now last one question I do. I will draw the diagram, and you have to do the solution, calculate the answer. Okay, so I'll draw. I think we have already copied. So this is question number 3 gone. Question number 3 gone. Now, first of all, you try to understand the question. What is that question? The angle of elevation of the top of a tower from a foot of the ground, from a point on the ground which is 30 meters away from the foot of the tower is 30 degrees. Find the height of the tower. Same as this one only. Height of the tower. Or, yes, same as this one, or same as question number 1. Same as question number 1. Height of the tower. Question number 4. So please draw the diagram. Angle of elevation given 30 degree. This is the foot of the tower. This is the foot of the tower. From here you are looking. This is A, this is B, this is C. C is the point of sight, D is the foot of the point, and AB is the height of the tower, and AC is the line of sight. So then, which is 30 meters away from the foot of the tower, 30 meters. So this distance is given now. This distance given 30 meters. And you have to find out this one. So long we have used only sine. Now, this is the first time we will use tan. Okay? So let's see. This one I just will show you, and then I will wind up. Okay? But you have to do the question number 2, then question number 5 and 6. You try. Otherwise, in my next video, I will give you the answer. Now here, AB is the AB equal to height of the tower. Angle of elevation is how much? ACB equal to 30 degree. Then what is the distance? Distance BC equal to 30 meters. So from and AB is the question mark we have to find out. Okay? From triangle ABC we get tan 30 degree equal to AB by BC. Tan is a ratio of perpendicular and the base. Okay? So tan 30 degree how much? It is 1 by root 3. Equal to how much? AB. And this is 30. So ultimately, AB equal to 30 by root 3. So tan root 3. So what is the height of the tower? Height of the tower is 10 root 3. Height of the tower is 10 root 3. Clear? So with this, I will wind up for today. But remember, my dear student, this chapter basically will depend on the diagram and the ratio of the sides. That is most important part. And that 30 degree, 40 degree, 30 degree, 45 degree, 60 degree, 90 degree, those measures you have to put in mind. Okay? So please practice this question. It is not so tough. It is easy. If you practice, you will get a good marks. Okay, with that, I'll wind up for today. Thank you and have a wonderful day ahead.